Welcome to Science Meets Adventure, where every landscape has a story, and every mystery leads us a little deeper into the planet we call home. Here's a question that has followed travelers, sailors, and explorers for centuries. Why does the ocean taste salty, while most rivers, streams, and waterfalls taste fresh? Stand on a windy coast, watch waves crash against black volcanic cliffs or bright tropical sand, and it feels like the sea has always been this way. But the truth is even more fascinating. The ocean's saltiness is part of a slow, epic Earth story written by rain, rocks, rivers, volcanoes, and time itself. Let's begin on land, because strangely enough, that is where much of the ocean's salt story starts. Imagine rain falling over mountains, forests, cliffs, and deserts. Rainwater may seem soft and harmless, but it is actually a quiet traveler with chemical power. As it falls through the air, it picks up a tiny amount of carbon dioxide, which makes it slightly acidic. Not dangerous, not dramatic, just enough to begin loosening minerals from rocks. Now picture that rain landing on a mountain trail, a rocky canyon, or an ancient hillside. Over time, it seeps into cracks and slowly wears rocks down in a process called weathering. As rocks break apart, tiny bits of minerals are released. These include ingredients like sodium, calcium, potassium, magnesium, and chloride. You may not see them because many of them dissolve into the water. Then streams gather, rivers form, and those rivers begin carrying the dissolved minerals across continents toward the sea. So in a way, every river is delivering microscopic luggage to the ocean. That is the first big clue. The ocean is salty because rivers have been bringing dissolved minerals into it for millions upon millions of years. Not all at once, of course. This is not like dumping truckloads of table salt into the sea. It is more like Earth slowly brewing a mineral soup, one raindrop and one river journey at a time. But here comes the next mystery. If rivers carry minerals too, why don't rivers taste as salty as the ocean? The answer is movement. Rivers are always on the go. They flow downhill, rush past stones, cut through valleys, and eventually empty into larger bodies of water. Their minerals do not stay in one place very long. The ocean is different. It is like the giant collection basin at the end of the world's waterways. Water can leave the ocean by evaporation, rising into the air to form clouds. But most of the dissolved salts stay behind. When seawater evaporates, the pure water goes up, and the salts remain. So over vast spans of time, the ocean keeps collecting more dissolved material. You can think of it like this. Rivers are delivery routes, but the ocean is the warehouse. And that warehouse has been open for an incredibly long time. Over Earth's history, this process has repeated again and again. Rain falls, rocks weather, rivers carry minerals, oceans collect them. The cycle never really stops. It slows in some places, speeds up in others, but over geologic time, it adds up to something enormous. What we taste in seawater today is not just salt from one source. It is the result of countless chemical exchanges happening across continents and deep beneath the waves, over timescales so long they almost feel impossible to imagine. Now let's go beyond coastlines and river mouths, down into the deep ocean where the story gets even more adventurous. Far below the surface, where sunlight never reaches, the seafloor is not quiet. In some places, underwater volcanoes and hydrothermal vents are constantly reshaping the chemistry of the sea. Hydrothermal vents form where seawater seeps down into cracks in the ocean floor, gets heated by magma deep below, and then rises back up, superheated and packed with dissolved minerals. These vents can look like chimneys on the seabed, pouring out dark mineral-rich fluids into the freezing deep. It is one of the strangest and most spectacular environments on Earth, like a hidden alien world that just happens to be in our own ocean. These underwater systems add and remove chemicals from seawater. As hot water reacts with oceanic crust, it changes the balance of minerals in the sea. Underwater volcanoes also release gases and materials that become part of the ocean's long chemical story. So the saltiness of the ocean is not only shaped by what comes from land, It is also influenced by what rises from Earth's interior below the sea. In other words, the ocean is being edited from above and below. Of course, the ocean is not getting endlessly saltier forever in a simple straight line. Some minerals are removed from seawater too. Marine organisms use calcium and other substances to build shells and skeletons. Some dissolved materials settle into sediments on the seafloor. Chemical reactions near the ocean floor can lock minerals into rock, so the sea is not just collecting ingredients. It is also constantly sorting, reacting, storing, and balancing them. That is why seawater has a fairly stable overall saltiness today, even though the planet is still delivering minerals into it. The ocean is less like a bucket filling forever and more like a giant planetary mixing system, with inputs, outputs, and constant chemical negotiation. Still, one mineral pair dominates the taste we notice most: sodium and chloride. Together, they form the main salt in seawater, the same basic combination found in table salt. That is why a wave on your lips tastes instantly familiar, even if the journey behind that taste stretches back through mountains, storms, tectonic plates, and deep-sea vents. And maybe that is what makes this story so beautiful for travelers and explorers. The next time you stand by the Atlantic, the Pacific, the Indian Ocean, or a remote island shore, you are not just looking at water. You are looking at the endpoint of billions of journeys. Every cliff weathered by rain, every river crossing a continent, every mineral freed from stone, every hidden vent on the ocean floor has helped shape the sea before you. The salty taste of the ocean is a reminder that Earth is connected in ways we do not always see. Mountains speak to coastlines. Rain speaks to rock. Rivers speak to the sea. And the deep Earth, through heat and fire, joins the conversation too. So why is the ocean salty? Because our planet has been slowly dissolving, transporting, mixing, heating, and storing minerals for immense stretches of time. It is chemistry on a planetary scale, but it is also a story of motion, landscape, and discovery. The sea is salty because Earth never stopped working, and that means every shoreline holds more than beauty. It holds history. Thanks for joining us on Science Meets Adventure. If this journey changed the way you see the ocean, give the video a like. Share it with a fellow explorer and subscribe to Science Meets Adventure for more stories where science and discovery meet at the edge of the unknown.